Okay, so here we have to explain the concept of the continuity of composite functions with examples. So what do you mean by composite functions? Uh, so the rule is that if f of x and g of x, if f of x and g of x are two real functions, then the composite function f of g of x is equal to f of g of x. Um, then so this composite function is defined. This composite function is defined whenever the range of g of x, whenever the range of g of x is a subset of the domain of f of x. The range of g of x should be a subset of the domain of f of x. So the theorem on the continuity of composite functions is written as the theorem on the continuity of composite functions is, so suppose f and g are two real valued functions, such that f of g of x is defined at x equal to c, So then if g of x is continuous at x equal to c, if g of x is continuous at x equal to c, and f of x is continuous at g of c, and f of x is continuous at g of c, then the function f of g of x is also continuous at x equal to c. Continuous at x equal to c. So based on this, we can solve one example, that is, if it is asked to show that the function f defined by f of x equals to mod of 1 minus x plus mod x, where x is any real number, is a continuous function. Where x is any real number is a continuous function. So we have to prove that this is a continuous function. So here, here the function g of x is defined as 1 minus x plus mod x, and the function h of x is defined as mod x for all x belongs to R. Then we can write h of g of x, that will be equal to h of g of x, which is equal to mod of, means it will be h of, so simply it will be mod of g of x, which will be equal to mod of 1 minus x plus mod x, which is equal to f of x. So now here, we know that mod x is a continuous function. Since why it is continuous for all real values of x. It is a continuous function. And also 1 minus x, which is a polynomial function, so it will be continuous also. Also 1 minus x is a polynomial function. It's a polynomial function. So it is continuous also. So it is continuous. Therefore, the sum of two continuous functions is also continuous. So the sum of two continuous functions is also continuous. So it means that we know that 1 minus x is continuous. So plus mod x is also continuous. So the sum of two continuous functions, which is g of x, that is also continuous. And h of x, which is equal to mod x, is also continuous. So therefore h of g of x, which is equal to mod of g of x, which is equal to mod of 1 minus x plus mod x, which is equal to f of x, is also continuous function. So this h of mod x actually, sorry, h of x, yeah, h of x is mod x. So h of g of x, since g is also continuous, so h of g of x, which is f of x, is also a continuous function. So hence proved. And similarly, one more example, suppose we can show that the function f of x, which is equal to sine of x square, is also a continuous function. Since why? Since if we take g of x, that is equal to, suppose, x square, and h of x, that is equal to sine x, then h of g of x, that will be equal to sine of g of x, which will be equal to sine x square. Now x square is a polynomial function, so it is continuous, and sine x is also continuous. So x square, which is, it is a polynomial, so it is continuous function, and h of x, which is equal to sine x is also a continuous function. Sine x is also a continuous function. So we can say that sine of x square, which is a composite function, is also a continuous function. So hope you have understood the concept of the continuity of composite functions. So thank you.